Hello and welcome back. This video tutorial is about partial derivatives. Just like one variable function, multivariable function also can be differentiated. Well, when we differentiate one variable function, for example, y equal x squared, we know how to find derivative. It's just 2x. We differentiate it with respect of variable x. X called independent variable and y is dependent variable. When we think about two-variable function z equal f of x, y, we have few choices. We can find first derivative over x variable, or we can find first derivative over y variable. Let us do some examples. If we have function z equal x squared plus y squared, well, we have two different variables here, x and y, and all of them are independent from each other. So we can differentiate this function with respect of variable x or with respect of variable y. So now instead of one derivative of first derivative, we had two first derivatives. So we differentiate in first with respect of derivative x, and I put this small notation here, derivative and with subindex x, meaning that we differentiated with respect of variable x. And for this, we think that y is just a constant for us. So this will be derivative of x squared plus y squared, just like before, with respect of x. Now we split it into two derivatives. And variable x we differentiate as usual. So derivative of x squared with respect to variable x is just 2x. And again, y for us is just a constant in this case, because we're differentiating with respect of x variable. So derivative of y squared in this case is just 0. Now same we can do with derivative over y variable. I will write partial derivative z prime with subindex y, meaning that we're differentiating over y variable now. And it's exactly the same procedure. So I split my function into two, because we have some of them. And I differentiate over y variable, thinking that x variable is a constant now. Derivative of constant is always 0. So x squared derivative over y will give me 0. And derivative of y, just using our formula, it will be just 2y. So derivative of this function will be 2y. Now instead of one derivative, we obtain two derivatives. Each of them are partial derivatives over variable x and y, respectively. Let us do one more example. Let us differentiate the following function. F of xy equal to x times y squared plus 6y minus 10. Again, if I wanted to find first derivatives, I wanted to find two of them, with respect of x and with respect of y. So partial derivative over x will give me the following. I have to differentiate the sum and difference of my function with respect of variable x. So as before, I would split it into three functions. And each of them I will differentiate with respect of variable x. Now y for me is just a constant and x is a variable. So first derivative will be like that. This would be the same as we multiply by constant times variable x, and when we differentiated the constant, we can bring outside of the differentiation. So basically what we have here is just derivative of variable x times some constant. So derivative of x times y squared will be just y squared times 1 plus. Here we have 6y, and we differentiating over x variable. This is just a constant for us, and derivative of constant is 0 minus. Now 10 is a constant and have nothing to do with variable x. Derivative of constant is always 0. So derivative over x is equal to y squared. Now we differentiate this function over y variable. Exactly same idea. I split this function on three functions, each of which I differentiate over variable 1. Now I think that x is a constant and y is a variable. Right here, I will have some constant multiplied by y squared. So constant we can bring outside of the differentiation rule. To obtain derivative of y squared is 2y times x plus derivative of 6y with respect of y variable will give me just 6. And derivative of constant n is always 0. For multivariable functions, we also can find the higher order derivatives. So we can differentiate them twice. For example, if we have function f of xy, z equal f of xy, we can find first derivatives with respect of variable x and with respect of variable y. And now we can differentiate second time. But in order to differentiate it second time, again, we have two choices. We can differentiate second time over x variable, and we can differentiate second time over y variable. So when we have first derivative over x variable, we can differentiate it 2 more times over x and y variable to obtain second derivative over xx and second derivative over xy. Same we can do here. First derivative over y variable, we can differentiate second time over x, and we can differentiate second time over y. In this case, we have now 4 different second order derivatives. Let us do some examples. Let's say we wanted to differentiate the following function. F of xy equal x squared plus xy plus y squared. Let us find all second order derivatives. For this, I have to differentiate this function first time and to find first derivatives. So derivative over x will give me the following. I'm differentiating each summand of this function over x variable to obtain 2x plus y plus 0. Derivative of y in this case is equal to 0 because we don't have any multiplication by x variable over which we differentiate. Now derivative over y. Same function, I'm differentiating over y variable thinking that x is a constant right now. It will give me derivative of x squared is just 0 because it has nothing to do with variable y. Derivative of xy, again, we're differentiating over y variable, so x is just a constant here. So it will be plus x times 1, and derivative of y squared is just 2y. So these are the first derivatives of our function. Now we have to differentiate it second time. I have 2 options now for the first derivative over x variable. I can differentiate it over x second time, and I can differentiate it over y second time. Let me differentiate it over x. So I take my first derivative over x, and I will differentiate it one more time, and again over variable x. It will give me 2 times 1 plus 0, which is just 2. So derivative of y is 0 here because we're differentiating over x variable. If I take second derivative over y, it's my first derivative over x, differentiated over y. It will give me 0 plus 1. So derivative of x with respect of y variable is 0, and derivative of y is just 1. So we obtain 1 here. Now we can find second derivatives with respect of first variable over y. So I can find 2 possibilities here. We can differentiate first derivative over y over variable x again. In this case, I take my first derivative over y, which is x plus 2y, and differentiate it over x. It will give me just 1. derivative over y will be 0 because it's just a constant, and derivative of x is just 1. We can differentiate same function over y again. So we take derivative over y and differentiate it over y variable one more time. Derivative of x will give me 0 because this is just a constant with respect of y variable, and derivative of 2y will give me just constant 2. So here you go, we obtained 4 different possibilities for the second order derivative. Now it's your turn to practice.